standardized scalar. That also it's increasing. Percentage is increasing. My question is very simple. See, whenever you're normalizing a data, okay. So here, in the case of in the case of Titanic, so you'll have a gender. Sorry, where is the gender? Sex. Okay.
Yes.
This is a female and male. You're using get dummies and you're converting, but this will become a class, right? This will become a class. Is it a good? And here also embarked is also a class. There are 3 different classes. Yes and
Yes.
Q.
Yes.
Okay. Is it a right method to normalize this sex and embark because they are class?
So I think we are not normalizing these columns, gender columns. So we are normalizing all the other columns which are integer or numerical type, but not the class type columns. Because class type columns, if we normalize, you will get some values which are in decimals, which makes no sense. So we will not normalize these class. The categorical variables should not be normalized because they are not any integer. Only numerical data can be normalized. And normalizing numerical data makes sense, but you should not gender cannot be normalized, p class cannot be normalized, okay, because these are classes. So we cannot, so because normalizing classes does not make any sense, because like if it gives you a gender of 0.5, that means nothing, 0.75 means nothing. Okay.
Okay, Vinay. That was my first question. So in the second question, here that is in the assignment. So that is you have done with the help of JointPlot. Okay. So JointPlot is giving me this graph. So with the coefficient of minus 0.0028, and this is P value or confidence interval?
This is P value.
P value is not confidence interval.
No, not confidence interval.
Okay. So P value. See, the thing is, when I plot this pair plot, okay, let me zoom out. Okay, when I plot this pair plot, what is the information that I'm getting? See, I have plotted this one, right? I have plotted this website time on website versus yearly amount spent. What is the information that I'm getting from this one? I'm not able to crack.
Okay, so like as you can see, there is no relationship as of we can see from these two graphs, right?
There is no relation.
So but like from the business perspective, we would see that if I'm investing more on my website, like if I'm investing more money for in my business, then so like for a website, the business is the website owners make business or make profit from the people who are visiting their websites, and for how long they stay on the website. Okay, so if people like using Facebook, Instagram, and this Quora, Reddit, if they're using these websites for a longer duration, then they are also, there is a high probability they are clicking on the ads. They're buying some stuffs from which are shown by ads on their websites. So, but here in our case, we find that there is no relationship with it for this particular data set. Okay, for this particular data, there is no relation. Or there is no correlation. That's why this Pearson's correlation is almost zero, right? So Pearson's R is that correlation coefficient, almost zero, right? So because you can see it's kind of a circular, so there is no relation.
Circular, it is zero.
So like it is for, but if the data is from a actual like some other data set or some other business, other domain, then we may find some see in this length of membership and amount of yearly amount spent has a relationship, right? And time on the app has some of the relationship, time on the app with yearly amount spent, right? But rest all of them are kind of rest all of them are kind of a normal distribution. No relation. They're kind of a normal distribution, because central we have more values in the center and there are lesser values on the circumference. So they are like normally distributed. So it looks like this data is randomly generated from a fake data set. Okay. But when you are doing analysis on a real data, you may find some relationship. So this is with this, like what I want to you guys to know, that you can visualize relationship between the different columns using a joint plot or a pair plot.
Pairplot. Pairplot. So Pairplot will be Pairplot will be one ultimate graph where you can find whether they are correlated or not.
Yes. But like if you have like 20-30 columns, then you cannot do Pairplot. Like you can do, but you cannot see that the size will be very small, because 20 words by 20 graphs. So like Pairplot is the ultimate thing to see the trend. Then like if you want to see how they are distributed individually, then we do go for a joint plot, because it gives you distribution on the axis also, right?
Yeah,
So
that is trial and error. Joint
yeah.
plot should be, joint plot is trial and error. We have to check for each one, whichever is having correlation.
Yes,
that we take
yes.
it. Okay. Okay,
Or
fine. Now here,
other way, or a better way of doing Pairplot is just go through the domain, like the business document. Then based on logic, you figure out which columns or which features can be more important. So if you have 20 features, but like based on like address, your pin code, maybe they do not form any useful information or the name, then you can remove some of the columns, some of the features, and based on like remaining 8 or 10 columns, on that you can do a Pairplot. So like all of this requires like somewhat 60 to 70%. It depend on the domain knowledge or the from the where the problem is coming from.
Okay.
Right.
So here, we had this one linear. We have plotted LM. This is just for analyze, right? What exactly is this one? That nothing else, right?
Yes. This is for just visualizing. So like if I fit a line, how well it fits my data. Just to visualize.
But we are doing here multiple linear regression, right?
In this plot, we are doing simple one-on-one, like one single.
No. I'm talking in the project. This is single, but the project is on multiple linear regression. We have taken different for different, that is session, time on app, website, length of the members, right?
Yes.
And the last question in this one is, see, we find RMSE here. RMSE is how much? We got some RMSE.
8.93. It was there above.
8.93. Okay.
Yes.
So 8.93. How to see? So I just wanted to verify how to verify that this is my good model. How to verify that?
So give me like what are we predicting? We are predicting here is the go above.
Time on is this one. Prediction is this one. What? 1 minute. Yearly amount spent.
So we are predicting yearly amount spent, right? And what is this unit for this one? The dollars, $billion,
unit
or
will
just
be dollars? Yeah, dollars. That's not specified actually.
Okay, just dollars.
That's
Then just take the mean. Take the mean of that column.
Mean of this column. What?
Mean of yearly amount spent. The mean of that column.
Okay, so I should run from the beginning, I guess.
No. Like you just look at the different data values in that column. So I think it is around 500 or like 400, right? The normal.
No, that's not loaded. Yeah.
No, I can.
This is mean is 500. 500.
So like when the mean like all the like the average amount spent is around 500 or like $450, and my error, the error that I'm getting with my model is like $8, $9. So like, can you like, so it is like suppose you went out to buy a watch, right? So the range in which you buy the watch is around 500 rupees to 600 rupees, right? But based on your model, which you like took data from Amazon watches, and your model is saying like the price of the watch is 500, but what your model is saying 510 rupees. So what do you think? Your model is good or bad?
Okay.
Good only, no?
Yeah, it's good only. Definitely it's good.
Yeah. So we have to this is a very good question. We have to always compare with the mean value of that particular y variable or the dependent variable.
Target variable.
So target variable. So if suppose if your RMSE was around $100 or $200, then you need to do some tuning in your model, right? Because if you are predicting a price and there is an error of 200 rupees, so like for a cost price of 400, your model is saying 700 rupees, then it is bad, right? With plus 10-20 rupees, it's fine. So it's like very good. I think like for this case, it is really good.
Otherwise, then I find R square.
Yes, R square is for like best fit.
R square.
See, it's almost one. See, it's very good. R squared is almost 1. Almost 1. Like it's very good. So like this is like Sujan, I really must like congratulate you. Like this is the perfect way of reporting your results. Like so like you finally so like in a way when you will make a report, you will say, okay, so this is what I'm getting an error. My model is able to predict with this much of RMSE, and like when I ran this R squared error, I'm getting this much of score. So this is validating. Okay, whatever you did is actually correct because this model is showing you that. So like perfect.
Okay. Yeah. Yes, Vinay.
Great.
Vinay, Vinay. I have, I tried Titanic data set, whatever the methods you taught me, like maybe I've gone wrong in that taking that categorical thing. I'll just go with that and I'll fix it. Okay. I have done
So,
it. I'll fix it later.
yeah, just normalize only the numerical columns, not the
Yeah,
categorical
I'll do
ones.
that. Okay. But still, Vinay, if I try also, I'll not get more than
84%.
80% or 85%. Yeah. I've
Yeah.
got it
So,
with 84% with this one. How to improve that thing?
so
How
like
to
maybe
improve the
like
efficiency?
this like maybe linear regression, logistic regression, and this k nearest neighbors is not a best model for this particular problem.
Model.
So like we can, so it is
Okay.
not the best model, right? Best technique, right?
Okay.
So it
Okay.
is like
Okay.
if I give
Yeah.
you
Yeah.
a so if I'm giving you a bouncer and you are trying to duck all the time, so maybe ducking for a bouncer is not a good technique. So maybe you should try a
Yeah.
pull shot. So like it is about a matter of
Okay.
which technique which suits which kind of data set, right? So maybe like today we were
Okay.
supposed to look
Okay.
at decision trees and random forest. So maybe like if you try decision trees and random forest, you can get a better result. Or maybe support vector machines
Okay.
can
I'll
give you a
try.
better result. So it is like
Okay.
juggling between different techniques. Whichever gives me the best result, it should be the technique
Hello.
that I will be using.
Okay.
I should be using, right?
Okay. Okay. Okay, Vinay. I'll try, Vinay. I'll
Yeah.
after that I'll try and later I'll come back. I'll come back.
Mm-hmm.
Okay.
So
Thank you so
this
much
can be
for clearing my doubt, Vinay.
this can be a really good exercise. Like if you try to implement all different methodologies on one particular data set, right? So you can, right. So
Okay.
for this
Okay. I'll
Titanic,
try.
you apply all
Yeah.
linear regression, logistic regression, KNN, and decision trees, right?
Yes, all will try and we'll put it a comparison table and maybe we'll come to know what exactly which is the best fit.
So that will be like
Yeah.
really great to report all the things. Okay.
Okay, I'll do that, Vinay. I'll do that, Vinay. Okay, thank you so much,
Cool,
Vinay.
cool, cool, cool,
I'll
cool.
stop sharing. Yeah.
Yeah.